Hello, my name is Roshni. Today I'm going to go an overview about our project that we did on Connect 4. Our project is a digital version of Connect 4 which is designed for two players. It features a GUI that allows players to have customizable board dimensions. They be able to choose the number of connected pieces required to win. The winning methods are vertical, horizontal, and diagonal. The software handles game logic, including players' turns, win detections, and draw scenarios. A key feature of our program is customizable board dimension that we are able to do with the extension, the minimum size of a 4 by 4 and a maximum size of a 20 by 20, allowing games to play the game up to their preferences. Our goal was to replicate the classic Canuck 4 game while also adding flexibility through customizable settings.
Alrighty. Hello, I'm Josiah Lucero. Now let's move on to the implementation. Generally, we split up the implementation of the program into four sections, starting off the main class. As you saw in the live demo, you had the home screen where the user can input game settings for the game they want to play, and then they actually had the game screen where you actually play the game. The main class is where the main function is and handles the switching between that game GUI and the home GUI. Now, moving into those individual classes, you have general GUI classes, which are suffix with the GUI prefix suffix, and they handle the general logic of handling GUI elements and input events from the user. Then you also have game classes, which the primary one for our program is the grid class, which handles the actual logic of the game, that for game, and handles the cases where you input different game sizes and whatnot dimensions for the game. And then you have general utility classes. I like to call them plain old data classes. They're just data that help store the game state and other functionality within the program.
All right. Hi, my name is Aryan, and I'm going to talk about different design options that we had for this project. So as you can see, we had two different options for this project. One of them was using specialized classes, and the other one was using pure classes. So it was advantages and disadvantages for each option, and we decided to choose the first one, mostly because it was easier to organize and understand, and also adding the new features was easier. And I would say the main disadvantage with this option was we had to do some extra work to connect all pieces together, different classes and together. And also the second option that we had, so it was harder to add new features, but it might be easier to debug because most of the code is in just in one place. But overall, we decided to go with first option. And here I would like to talk about the most important lessons that we learned in this project. So one of them was the basic object-oriented programming concepts. So in this project, we learned more about objects and classes and their association in Java. So how to use objects in the project. And also we learned more about benefits of UML diagram. So using UML diagram made this project much easier to understand. And another important lesson that we learned was the importance of testing. So we learned that having a good plan for system tests and unit testing would make the project easier. And also it will improve the functionality of the project.
The system tests for our program were intended to check the validity of the boundary values for user input dimensions and win lengths, as well as all the possible ways in which a game could be won or lost or pieces placed, including situations where the column or grid was full. This system also tested the GUI for the game and helped catch an issue where the program was successfully compiling from VS Code, but not the terminal window. And after that issue was rectified, the tests were successfully passed and the program functioned as expected.
Moving on to our next section, which involves the two major problems that occurred during implementation and testing. The first one, which we mentioned before with regard to public and private accessors. During compilation through VS Code by just pressing F5, no problems occurred, but when we compiled to the terminal, we got compilation errors during system testing, which involved public and private accessors, which came down to errors with incorrectly setting the private public attribute of method field or classes, or was remedied through getters and setters. This error also showed up after playing the game after the completion of the terminal, where certain actions would be registered or be unresponsive, as it would trigger an exception regarding public and private accessors, which would lead to an unresponsive program. Which then moving on from that, those were one major problem that occurred during testing. During the initial implementation, a certain state that wasn't considered was that during Connect 4, you could theoretically win through a vertical, horizontal, the diagonals, basically multiple lines of winning in a certain win state. It was not initially considered, but now is handled gracefully after that was taught during system testing. And here is a live demonstration of that, which as you can see, it is gracefully handled. Which that really includes two major problems that came up during implementation and testing. Every other problem were minor in comparison and wasn't too hard to handle. So that is it. Thank you for viewing my presentation. I hope you have a wonderful day.